On the top and bottom of the screen, we have two of the most common instruments used to collect and visualize acoustic data. First, I'm going to describe what information is shown in each of these individual displays, and then I'm going to give you a moment to answer for yourself how you would describe the most important difference between what is visualized in each of them. A spectrogram is a visual representation of the frequencies in an acoustic signal over time, where the y-axis is frequency and the x-axis is time, and there's an additional dimension representing the amplitude in the form of gradations of darkness. That additional dimension is what allows us to see formants as dark horizontal bands. An LPC spectrum also visualizes the frequencies in an acoustic signal. The x-axis of an LPC spectrum is frequency, like the y-axis of the spectrogram. And the y-axis of an LPC spectrum is amplitude of that signal. Because the y-axis is amplitude, that's why we see the formants represented as peaks vertically. So take a moment and answer for yourself, how would you describe the main difference between what's visualized in each of these displays? Time's up. What's the answer? There's no passage of time represented on the LPC spectrum. You could have also said there's just more information. You can see more details about the characteristics of a speech signal on a spectrogram. This is all equally true. Data from both instruments visualize all frequency components of an acoustic signal, but only the spectrogram shows how those frequency components change over time. At any individual moment on a real-time LPC spectrum, you're just going to see how those frequency components look at a static moment of time. While on a spectrogram, you'll see not only this frequency data, but how this data changes dynamically over time. In our textbook, it states that the choice between using a spectrogram and an LPC depends on what information you want to acquire. Honestly, it's pretty amazing how, let me stop this, how much information is able to be packed efficiently into a spectrogram. So for many purposes, that makes it a better choice. If you want to identify, quantify, otherwise analyze in detail the acoustic properties of speech sounds or categories of speech sounds like fricatives or plosives, you want a spectrogram. But for treating misarticulation of R, we're primarily concerned with being able to clearly identify where formants are. And we want young children to be able to understand and interact with what they're seeing. On both measures, the LPC spectrum is a better choice.